Alright, so here I'm dealing with the cost equation. They wanted me to find the average cost and then find the minimum average cost. So to find the average cost, you just take your C value and divide it by x. So when I do this, I get 0.001 x cubed plus 5x plus 250 all over x, which I could reduce, right, and just say that this is 0.001 x squared plus 5 plus 250 divided by x. If I take the x divided by that term and that term and that term, this is what it would give me. So now to find the minimum of this, I would just take the derivative of it. I get that critical point, and the critical point leads me to a min or a max. Again, graphing it lets you help. It's an easier way to help determine if it's a min or a max. But if I take the derivative of this, I would get 0.002x. Derivative of 5 is 0, and let's remind ourselves that 250 over x is the same thing as 250 times x to the negative 1. So I would get minus 250x to the negative 2 as my derivative. So now if I set this equal to 0, I should be able to solve for x. And hopefully it'll get me somewhere around that 50 mark that I had earlier. I'm going to go ahead and move my 250x squared to the other side. That's going to be equal to 0.002x. Yep. Multiply both sides by the x squared. Divide by 0.002 on both sides. I'm going to break out my calculator for that one. So if I do 250 divided by 0.002, I get some nice healthy number. Oh, that would have made sense. 125,000. And now if I take the cube root of both sides, and the cube root of 125,000, hopefully that's going to give me my answer of 50, which seems right, and it does. So algebraically doing that one, again, average cost is that. This is a critical value, and we could verify graphically that it's a minimum. Let's look at the one that I messed up on Desmos a couple times and doing it algebraically. So we were basically given a couple points, 350, 45, and 335, 46. So if they're doing this one by hand, you would want to find the slope first. So I'll do 46 minus 45 over 335 minus 350. Again, that's just using y2 minus y1 over x2 minus x1. And so I'll get this 1 over negative 15. So that's my slope. So now I could do a y minus y1. I'm going to use this point. Equals my slope, x minus 350. I could expand 350 divided by 15, or multiplied by 1/15, is 23 1/3. But again, I have to add this 45 over here. And so my price equation, so what is that, 68 1/3, and I think that's what we had. So my revenue equation is going to be my price times how many I sell, x. So I get negative 1/15 x squared plus 68 1/3 x. To find where I maximize revenue, at what quantity do I maximize revenue, I would take the derivative of this, which would be negative 2/15 x plus 68 1/3, and I solve that for 0 to find that critical point. I think that's what I had. Subtract the 68 thirds to the other side, so I have 68 1/3 divided by the 2/15, and I get x equal to 512.5. So now I'm going to take this 512.5, plug it back in over here to figure out my price. My y was my price. So I have negative 1/15, so my y was my price, times 512.5, and then lastly plus 68 1/3. So when I do that, plus 68 1/3 is where I get y equals to 34 rounding to 2 decimal places, since I'm talking about price, 34.17. So again, you saw the visual and the mess ups with Desmos, and here's the algebra for it. And the last one, just to figure out elasticity, they gave this formula as p over x over the derivative p with respect to x. And so we had a price equation, nothing crazy, 30 minus a whole bunch of decimals. Let me put my 0 in there. So 30 minus 0.005x. So if I'm finding out the elasticity of it, I have this equation. I divide it by x, and then I also divide it by the derivative of p with respect to x, which that would just be negative 0.005 for this one. And they were looking when x is 25, so I'm just going to plug in 25 for x here. And when I do that, let's see, I get 30 minus 0.005 times 25. Divide that by 25, and now divide that by negative 0.005. I get negative 239. And from the book, if the absolute value of, I think the Greek letters eta, EDA, I'm not Greek, you get something greater than 1, and so if it's greater than 1, that means it's elastic, and that's why we got that choice.